All right, welcome to NBH Academy.
All right, our learning goal we're talking about is we have to create a generalized graph of the reabsorption of glucose in order to demonstrate how protein-mediated renal transport can reach saturation. Mark on the graph where transport maximum and renal threshold occur.
So first we're going to draw a picture of the graph with the x-axis being the plasma substrate concentration, and the y-axis being the rate.
Okay, before we start labeling too much, let's go ahead and take a step back. And define our terms. We'll start with saturation. Which simply refers to maximum rate of transport when all available carriers are occupied by substrate. So, on the graph where we would see that would be this point right here.
Alright, next thing we're going to look at is the transport max. This simply is the maximum rate that reabsorption can occur. And this would be right here when this here, the rate transport, becomes the same because saturation has been reached.
Like a little additive. And the next part, the renal threshold. Is the concentration in the plasma at which glucose is first seen in the urine. And that would also occur right here.
So, in other words, where these two meet is going to be where our saturation is at.
So,
Agree?
I would agree.
Okay.
Yep.
So, let's look at a different graph. Say I've got this different organism. Over here we're going to keep rate. Over here we're going to keep plasma substrate. Let's say right here for this, say this is a human, this is about 4. Just going to basic, nothing too much. Rate of 4. Here, say we've got 6. Plasma substrates stay the same. We've got a graph that looks like this. Now, what would we think could more efficiently reabsorb glucose from the blood?
So for starters, this relationship here is a proportional relationship in both organisms. And then you have a zero slope reached here. So because this value is 6, essentially it can absorb more glucose than the human organism at higher concentrations in the plasma.
So we'd expect it to be more efficient, at least in the sense of being able to absorb glucose, more glucose.
Yes.
Correct?
Yeah, so when glucose higher concentration, at this concentration of 6, a lot of glucose in the human would be seen in the urine, while in this organism at 6, no glucose would be seen in the urine because that's at its transport max and saturation.
All right. So, how else can we break this graph down, guys? Let's think. Filtration is a constant. It doesn't have a saturation. And so, if you graph down the line, it just keep going on, never plateau. Excretion. All you make.
So, and then also the amount that is excreted is equal to the amount that's filtered minus the amount that's reabsorbed. And ideally, your excretion amount should be 0 when your filtration and your reabsorption is equal to each other. So let's say your filtration is 6 and your reabsorption is 6, then obviously your excretion amount is 0.
That would be like the max point right here, because you're not having any glucose in the urine at that point.
So for glucose, can't the equation be rewritten? I'm going to go ahead and erase some of our first graph. We'll go ahead and take out the first graph. For glucose, it'd be glucose excreted is equal to glucose filtered minus glucose reabsorbed. So on this, how would we be able to calculate that?
You've got a filtration. Filtration never reaches saturation because
Okay.
filtration can go on at any time. Your reabsorbance, that's what we've shown right here. So your excretion would begin where your renal threshold is, right here. So say you get filtered in a lot of glucose from the blood from the kidneys, and you can't reabsorb all of it. This amount here is what would actually be excreted into the urine.
Now let's say in another graph, that this organism has some kind of problem with its carrier proteins that pick up the glucose and reabsorb it. How would that affect this graph?
Well, this you'd expect to stay the same because it's still proportionally equal, so it'd still be a line going similar. However, since it can't reabsorb as much a certain solution, you'd expect it to be lower. Correct, Nick?
I think so.
That'd be my guess as well.
Yeah, I like that. Alright, guys.
I feel like we have more than covered everything in our learning goal. So, if you have any other questions, feel free to post and comment. We'll do our best to answer them. Thank you for joining us today on the NBH Academy, guys.
Now that's what we call learning.